Okay, I'm gonna be providing a short video with a couple examples from chapter 10, which is the hypothesis testing. The first example is about testing the proportion. Let's read the question together. Based on previous surveys, a newspaper made a claim that the proportion of US adults who believe in ghosts is more than 25%. A survey of 800 randomly selected US adults found that 215 of them say that they believe in ghosts. Can you support the claim at the 5% level of significance? So this is a claim about the proportion, so we need to verify this claim by performing a hypothesis test. The first step is to state the null and the alternative hypotheses. And since he says the proportion is more than 25%, since more should be in the alternative hypothesis, so that will be P, which is greater than 25%. And as you know, the null hypothesis is the status quo, it's the equal sign. So you just have to put equal there, 25%. And the claim is in the alternative hypothesis. He gave us the sample size, which is N, 800. He gave us the number of successes, the number who said that they believe in ghosts, which is 215. And he gave us the level of significance, which is 5%, 0.05. That's all we need to perform the test. Now I'm going to bring the calculator up and show you how we can perform this test. So you're going to go to stat, and then you go to tests, and then you go to one proportion z test. It's a test of the proportion. You press enter. Okay. P0 means what is the value in the null hypothesis, and we put 0.25, I believe. And now we need the value of x, the number of successes. X is 215. And 15, and then we move down. 800 is the value of n. Then, before you hit calculate, you need to decide what sign did you put in the alternative hypothesis. What you put in the alternative, you put the greater than equal sign. So you just go select it and press enter. Make sure to press enter. Color, it doesn't matter if you have this feature or not, and you can hit calculate or draw. Okay, the test statistic is Z, which is 1.22. This is step number 2. And the p-value is the most important step because based on the p-value, you're going to decide whether to reject the null hypothesis or fail to reject the null hypothesis. So 1.22 for the test statistic and 0.1103 for the p-value. So let me write them down. Let's go to our document. So Z is 1.22. Is the claim in HO or H1? It was in H1. You can call it HA. They call it HA in some other books, alternative hypothesis. Is this test a right, left, or two-tailed test? Because the alternative sign has a greater than, it's called a right-tailed test. What TI calculator test are we using? We are using the one prop Z test. You can do that also on StatCrunch by going to stats and proportion test and selecting one sample, providing the value of X and N. Let's scroll down and write down the value of the p-value. So the p-value is 0.1103. And what was alpha? The significance level alpha was 0.05. Would you guys agree with me if I say this is greater than alpha? If the p-value is greater than alpha, you fail to reject the null hypothesis. If the p-value is less than alpha, you reject the null hypothesis. In this case, we're going to fail to reject the null hypothesis. And to justify your answer is what I just did above. And the conclusion in word, when you fail to reject the null hypothesis, you state that there is not enough evidence at what level of significance? At the 0.05 level of significance to support the claim. When you don't reject the null hypothesis, that means you cannot support the second one. If you don't reject something, you kind of accept it. So that means probably it's good. That means the second hypothesis is not good. And that's what we're trying to say here. There is not enough evidence at the 0.05 level of significance to support the claim that more than 25% of US adults believe in ghosts. So this is the first question. I'm going to do another one testing the mean right now. Okay, here's the second question. The Metropolitan Bus Company claims that the mean waiting time for bus during rush hour is less than 10 minutes. Let's write the null in the alternative hypothesis. The less than, guys, has to be in the alternative hypothesis, and that's the mean, less than 10 minutes. That's the claim. And what would be the null hypothesis? The equal. All right. A random sample of 26 waiting times, so n is 26, has a mean x bar of 9.25 minutes with a standard deviation s of 1.75 minutes. S, not a population standard deviation, it's S. And when he gives you a sample standard deviation, you must use a t-distribution, which is the t-test. At alpha equals 0.05, test the claim. Assume that the population is normally distributed. So we've done the first step, which is stating the null in the alternative. Is the claim in HO or H1? It is in H1. Is it at right, left, or two-tailed test? Because the sign is less than, this is a left. What TI calculator test we're going to be using? We're going to be using the t-test. When you go to the calculator, guys, you see a z-test and t-test. By mistake, students go right away to z-test because it shows up first. But you only can use the z-test if he gives you the population standard deviation. Most of the time, he doesn't. So most of the time, it's going to be a t-test. So now let me show you how we're going to perform this test using. So t-test, you go to stat test, t-test, enter. I don't have data. If you have a data set, a raw data, you do data and you put the data in a list. But here I don't. I have a summary, so I just go to stat. I didn't select it well. I have to press enter, enter, and now we're good. Okay, what value we're testing against is 10. What was the value of X bar? I forgot, so I'm gonna check. Okay, so X bar is 9.25, S is 1.75, sample size is 26. And now I have to choose the sign in the alternative hypothesis, which is less than. Make sure when it blinks, you have to press enter to select it. And then you can go to calculate or draw. And the test statistic is negative 2.185. And the p-value is 0.0192. So negative 2.185, let's write them down. That is the test statistic. And the p-value, 0.0192. We're testing against alpha 5%. Would you guys agree with me that this is less than alpha? If the p-value is less than alpha, then HO must go. So we're going to reject HO. And to justify your decision is what I did here. I put p-value is less than alpha. Now we're going to write the conclusion in the context of the claim. Let's do that. So you state there is, when you reject HO and your claim is in H1, so you reject the first one, that means the second one must be good. So you support the claim. There is enough evidence at the 0.05 level of significance to support the claim that the mean waiting time for a bus is less than 10 minutes. And that concludes the two questions.